Hi, everyone. I think we're just going to give a minute or two to let people roll in, and we can introduce our speaker and start the presentation. Okay, maybe I'll wait till 12:03 and then I'll start. Okay, why don't we begin? Hi, everyone. I'm Elliot Martin. I'm a data scientist at the Center for Health Informatics and the PRDS group in Health Shared Services. I'm substituting for Kathy Eastwood today, who is at a conference in Ottawa. To introduce the CHI first, CHI, we focus on all aspects of the data pipeline, from data collection to analytics and custom displays. We aim to transform health data into evidence for community by collaboratively developing innovative methods in health informatics for precision health. The speaker series introduces the great work of colleagues in the field of health informatics. And today I'm delighted to introduce our speaker, Lindsay Hracs. Lindsay holds a PhD in linguistics and has channeled her fascination with language and information processing into a career in data science. As the data science lead in the Kaplan Global Epidemiology Lab at the University of Calgary, her work leverages machine learning and data visualization to support research in inflammatory bowel disease. She also develops interactive web applications that make research accessible to patients, clinicians, and policymakers alike. So a great fit for our speaker series, and thank you for coming. So please put up your hand if you have a question, or write it in chat or in the Q&A, and I can unmute you if you want to speak, or I can read your question if it's in the Q&A. And with that, please welcome Lindsay. So thank you for coming.
Right. Thank you so much for having me here today, and thank you everybody for attending. So I'm just going to share my screen here. Okay. All right. So I'm here to talk to you today about essentially taking static data visualizations into a dynamic area. So looking at interactive data visualization specifically with Shiny apps through R or Python. So first, I want to talk a little bit about why we might consider making a visualization interactive. So the side-by-side on the slide here tells the course sort of the core story of this talk. So we have some static data here on the left side. It's the types of plots that most researchers make every day. It's clean, it's accurate, but it's fixed. So it's published in a journal. This particular study is something I worked on with James King. And so the only way we could actually see a different year breakdown or a different geographic breakdown would be actually to go back and rerun the code and recreate the visualizations, which is for published data is typically not possible because we're usually limited to the numbers of figures we can actually put in a journal. So really, they exist on screen or in page, and we can't really update the figures as new data comes in. But here on the right, we have essentially the exact same underlying data, same chart type, but we now have some ability to interact with the data and visualize the data in different ways. So here, ironically, I'm presenting a static image of an interactive scenario, but we will look at a little bit more into what interactivity actually looks like. So I want to reiterate throughout the talk that both approaches are valid. Both serve very different purposes, and really understanding what one you need is a big part of sort of like what we can do as data scientists. Static plots really force you to anticipate every question in advance, but interactivity essentially lets the audience ask and answer their own questions. So follow-up questions that might come from a static plot can't necessarily be answered immediately without actually going back to code, regenerating plots. Because we do often get questions sort of like, can you rerun this for this year? Can we look at this data stratification, that sort of thing. And so interactivity essentially allows us to build that into both our workflow pipeline as well as our publications. So as I said, really static figures really help you answer questions that you thought to ask ahead of time. Whereas interactive figures let your audience ask and answer their own questions in real time. So some considerations is that interactivity actually comes with costs. So it does take more time to create these tools. And oftentimes there are deploying and hosting infrastructure that are required. And so it may not always be possible to do these things, and it may not always be worth it. So, for example, if you're writing an abstract for something, a static figure might be just enough for that. That being said, abstracts are really like, so few words, so few characters. So sometimes putting a link to a Shiny app might take, 30 characters, but might allow reviewers to get a better sense of your data, your project, and things like that without actually using word count. So there's kind of a trade-off, right? There's a little bit of time involved and sometimes infrastructure costs, but it's something worth exploring, but it is really a project-dependent sort of question you might ask. So for today, we're going to look at some fundamentals of data visualization that are going to hold across both static and dynamic data visualization. I'll talk a little bit about what, excuse me, what Shiny is and the interactivity landscape. And then we'll look at some of the building blocks of a Shiny application. This is going to involve looking at some code. So for some people who are familiar with R, you'll kind of have an idea of what I'm talking about. But if you're not familiar with R, this is still going to be accessible for you because I'm going to talk about it in terms of like sort of the logic of what a Shiny app does and interactive data visualization. We'll talk a little bit about deploying a Shiny application, and then I'm going to walk through some examples and share some resources, and then there'll be time to ask questions as well. Okay, so some fundamentals of data visualization. So before touching Shiny at all, it's worth talking about some of the principles that are going to apply regardless of whether our data visualizations are static or interactive. So these aren't new ideas. If you've done any data visualization, these are things that you're going to have considered already, but worth talking about as well. So essentially, you can't really do interactive or dynamic data visualization if you're not choosing the right chart type for your data in question. So it just sort of holds that we need to know our tools ahead of time. If it's a good plot in a static version, likely it's going to translate to an interactive version a lot better. Clarity also really matters. So using visual cues to encode data clearly, and these sort of things are amplified when we have interactive data visualization. So things like position, color, size, all of these sort of have a visual encoding hierarchy. We know that position tends to be the most reliable, so a bar's height or a dot's location on an axis is a lot easier to compare. Color is useful for categorical distinctions, but harder when we're doing quantitative comparisons. Size being sort of the weakest in coding, it's a lot harder for people to actually see size differences on a plot. So those are all the things that we need to keep in mind. So the implication really is that your primary data dimension should always be encoded in ways that we kind of think about when we're making a static plot. So simplicity, really, you want to set the goal to reduce the cognitive load. So somebody should be able to look at a figure and know the story, independent of having the text that goes along with telling that story. So same principles apply here. And then, of course, accessibility. So you want to make sure your designs are visually impaired friendly. So this is something that's really important. And so I wanted to show right here a an interesting exercise in color blindness. So we see here the first 5 default colors from ggplot2. You see these in papers all the time. People typically go with just sort of the base colors that come up. But we do see with the 3 most common types of color blindness, we don't actually get the same distinctions that we get when those 5 colors are presented just as their default. So I like to think about it as this way. In a room full of 50 people, there's likely 2 or 3 people who can't distinguish between these 5 colors here. So there are tools that can help us do these things, and these all matter very much for Shiny as well. So things like color, our color brewer, Viridis, so those color palettes that we know are visually impaired friendly. And also considering adding things like image alternative text to our images. And so there's some best practices. So if you Google just sort of best practices for doing the image alt text. And so this actually matters quite a bit because there are screen readers like VoiceOver for Apple or built-in tools that for Google Chrome, but it requires those of us building web apps to make certain design choices for optimal accessibility. And these things, again, really matter for a Shiny app because we're taking it to a whole other level of complexity when we're building an interactive plot. So really think of Shiny as a lens. So it's going to magnify whatever's already there. If your chart type is right, your encoding is clear, and your layout has a logical flow, adding interactivity is going to make it more accessible, more useful, and you're going to have a more impact. But if we have weak foundations, interactivity is going to cause more problems. So for example, if you had a pie chart that, let's just say, had 17 different stratifications, already that's going to be really hard to read in a static format. But then when you take it to an interactive format, what you're thinking of is that's like 17 different selections somebody has to contend with. If they're wanting to actually visualize what one of those stratifications looks like, that's a drop-down menu with 17 different options. And those sorts of things, again, are amplified when we're using Shiny. So all sorts of things to consider when we're building interactive data visualizations. Okay, so what is Shiny? So Shiny is a web framework for building interactive applications directly from R or Python. So the keyword in this definition is directly. So there's no translation step where you need to take your R analysis and hand it off to a web developer to turn into a web application. So you write R or Python code, and the Shiny package handles the rendering, the browser communication, and the reactivity. So the result is that you write code you already know, and Shiny really handles it. So there's no HTML coding, there's no CSS coding, there's no JavaScript required, though it can be integrated, and some of our apps do integrate these types of things because there are certain complexities that you can build out that just are not possible with Shiny. But to be totally honest, you can build very interactive apps to visualize pretty much anything with just knowing R or Python. or alternatively, knowing someone that knows R or Python to build a Shiny app for you. So when should we reach for a Shiny app? So in terms of one of the things we use this for in the Kaplan lab is we use Shiny apps a lot for data exploration. So analysts can really dig into a new data set, and this often helps us define a direction and frame results and really get a sense of our data. So we can slice data interactively rather than creating and editing a bunch of scripts to run a bunch of different plots and then open a bunch of different plot files. So what's great about this is we can upload a data set that has sort of some base plotting, and we can look at the data set and we can look at distributions and we can use this interactivity to our benefit when we're actually exploring data. In terms of reporting, this is going to significantly reduce the number of reruns when you're presenting to API. So this has been really helpful for us if we create sort of a Shiny app that we then send off. And oftentimes what happens is a lot of the questions we would get are answered with a Shiny app, but then often it allows our PIs to sort of like get a sense of the data that wouldn't be possible just if they were looking at a spreadsheet or looking at a few static images. It's also nice if you do have a recurring deliverable because you can replace that with a dashboard that can be updated easily. In terms of access, so colleagues who don't write code get a usable interface to data that they couldn't really explore otherwise. So it removes technical expertise as a barrier if you're giving somebody a web app and allowing them to sort of parse through the data themselves. And it's also helpful for timeliness. So again, there's a little bit of a component of building it out ahead of time, but what's great is that when underlying data updates, the app updates with it. You give it a new spreadsheet, and the app is already updated. So that could be like hundreds of visualizations just updated by putting one more CSV into the app infrastructure. So no one has to rebuild or send a chart every time numbers change, which is really nice. Okay, so tools like Tableau and Power BI are really great for non-technical users to build their own dashboards. But Shiny has a little bit of an edge when, one, your workflow is already in R, so data cleaning, modeling, and visualization all happening in one place. You might need some programming flexibility, so you're not limited with like drag and drop and those sorts of things. You might also want some statistical depth. So things like we can get modeling outputs, we can do complex simulations, we can do custom plots, and these are things that BI tools typically can't do or can't do to the extent that R can do or Python can do. And then also there might be a case where cost matters. So Shiny is free and open source. So especially if you're using it internally, you're not deploying apps that have shareable links. This is a really great tool, whereas BI tools often carry per seat licensing with them. So I want to reiterate though that these tools really aren't competing for the same use case most of the time. So BI tools are going to win a lot of the times when an audience needs to build dashboards themselves without actually knowing coding. But Shiny is going to win out when an R user or a Python user is building something with some sort of statistical depth or tight integration with an existing workflow. So they're both excellent tools. It's just kind of like a matter of what really is the use case behind them. So in terms of the interactivity landscape, so here we're kind of going from static images up to fully reactive. And so there is a spectrum of options here. And so here are some plots from a paper we put out last year in Nature on the global evolution of inflammatory bowel disease across epidemiologic stages. So we did include in our paper static images, but we did also host a series of interactive plots in our GitHub that were just sort of HTML files that let people explore per country data. As well as like a fully reactive Shiny app. And so I'm going to take a second here to pop out of the PowerPoint presentation to sort of explore a little bit about what these two levels of interactivity look like. So essentially, yeah, a static plot is really just going to be like kind of what you see here with these heat maps on this here. So we essentially have, um, 4 different panels. This is not going to change with the publication. We could essentially put this into an interactive dashboard as well, but this is sort of like your base plotting. I'm going to then pop over to my browser window. And so this is sort of like the first level of interactivity here. So can everyone see a plot that says Canada at the top? Yep. Okay, great. So this is sort of interactivity in its basic form. So this is a plot that's built with Plotly. Um, it essentially is just a paneled scatter plot and box plots, but we do have a level of interactivity here in that we get some information from our points. We can do some zooming and that sort of thing, and look at distributions in a little bit of a different way. And then we can reset all of that, which is here. So this is sort of a nice thing that you get without even integrating Shiny at this point. Is Plotly is a great tool for just sort of an interactive plot. We'll often share these. So we do a lot of systematic reviews in our lab, and what we'll do often is curate a plot like this with our systematic review data, and then we'll send it to data custodians in certain areas to sort of like review the data, and it's really nice in that respect. We also with this particular project built out a Shiny app. And so this is our Shiny app, which houses all of the data that you saw essentially here, and allows users to get a full experience of what our data set is and what went into our analysis. So these here, we have some interactive maps with rates. We have ability to actually make selections. So here we're looking at an overall inflammatory bowel disease, but if we wanted to just look at visualizing Crohn's disease, we click that and it updates the map. And so these are all like, it's got sort of like standard map functionality. And we can look also historically. So here we've built in a time slider with an animation. I'm going to start maybe in the 90s where data get a little bit more interesting. It's pretty sparse a few decades ago, but we can see here that we've actually built in an updating so people can look at how distributions change over time. We can pause and play that. We can scroll to particular years. And all of this is really nice and gives people a sense of what data went into our analysis. And what was great about this is we just published a link that is this long here at the top, and all of this is there. So it's nice for open access requirements and that sort of thing. With this particular app, we've also have a full data repository. So this is searchable. I always pick on my lab manager, Stephanie Coward, but we can see here all the papers that come up with her name on there. We can filter by region, all of those sorts of things. And what's also great about this is we've allowed people to download the maps they create, download data snapshots and things like this. And this app in particular gets about 200 hours of use per month that we're logging. So this one's quite a bit popular. We've had people ask for updates to the data and things like that. And what's great is we can put a new spreadsheet in as data come in, and this whole thing is sort of a self-contained system. Okay, so I'm going to go back to my presentation. I might have to advance through some slides real quick. But yeah, this sort of gives you a sense of the different levels of interactivity there. Okay. So the building blocks of a Shiny application. Can everyone see the slides again? Perfect. Okay. So a Shiny application essentially has sort of 3 components, 2 main components, and then sort of the component that links them together. So the user interface is the front end. This is what the user sees, the layout, the input controls, the placeholders, where plots appear, those sorts of things. And then the server is where your R code really does its magic. So things like filtering data, fitting models, building charts. And this reactive part is sort of the glue that connects them. So this is where Shiny does something that's really clever. So this is the system that connects the two. And it essentially builds your entire Shiny app, your data filtering and things like that through what the user wants to see. So we take in inputs here. This reactive change is triggered by those inputs, and then at the server something happens, and then we go back and see it at the interface. So there's a lot of stuff happening. Most of the time it happens quickly as your Shiny apps get bigger. As I know mine typically work slower when I'm on a Teams or a Zoom call at the same time, those sorts of things. So you're limited to the internet, but at the same time, this all really happens kind of in real time for people. So we can think of this, yeah, sort of as like the three main components of what a Shiny app is. So the user interface typically contains three things. We have layout functions, which control the visual appearance, the responsiveness. These things are commands like fluid page, sidebar, title panel. We'll look at some code as well. Input functions, which define the controls users interact with. So when I was clicking on the slider, that's a slider input. Select input is our drop downs, those sorts of things. And then we have our display output functions. So these specify where plots, text, and tables will appear on your Shiny app. Okay. So as I said, there's this reactive part of Shiny apps. So um, the user essentially makes selections, and then the app does some processing to display those selections. So for slider inputs, there's numeric ranges. These take in years, counts, thresholds, those sorts of things. Drop-down menus are going to take categories, regions, some sort of metrics that you might let people select on. Typically, we don't put more than about 5 things in a drop-down, though there are ways you can kind of filter in a drop-down where you might throw, I think we have one of our drop menus has about 100 different countries, but it allows users to search within a drop-down and that sort of thing. So again, making it as easy as possible for the user. Text input, which is like free text entries, so where I put an author name in to subset our repository, and then action buttons, which trigger a specific action or calculation. This is sort of like equivalent to like a back button or like where you might click a download button, those sorts of things. So each input has a unique ID and a default value, and we'll look at what this looks like in a second. So the UI inputs are connected to the server with this input ID tag. And when the value changes with user input, dependencies are automatically updated. So again, it's all kind of that nice automated pipeline where we as developers don't really have to do much. We just have to give people the tools to search through our data. So we know what our data stratifications are, and we just let people look through the data that way. So outputs essentially are the placeholders that the user interface and the server fills in. So here, these placeholders like plotly output or plot output, plotly output. So plot output is going to be where you might put a ggplot object. Plotly output is where you would put an interactive plot. We have basic tables. We have interactive data tables. And these are all essentially rendered through this server render function. So these are how you link those things between the user interface and the server. And so this is all like if you're interested in building Shiny apps, there's great tools online, but I think one of the biggest things that are missing is actually this logic that I'm talking about, because it kind of just assumes you kind of know user interface goes to server, but it's sort of these like linkings here that are really kind of hard to set your mind sort of on how they interact with each other. And so that's kind of what I'm hoping to do with this talk today. It's by no means going to tell you how to fully build a Shiny app, but I'm hoping by talking through some of the logic when you actually go to build your own Shiny app and look at those guides, it's going to make a little bit more sense. So really to keep the apps fast, the outputs are lazy. Recalculations only happen when the inputs, they depend on our change. So again, when users make a change, those sort of recalculations happen. So this is essentially here a complete skeleton of a Shiny app. There's going to be things that I couldn't fit on the slide. So you're going to have to like load libraries, load data, those sorts of things that you normally do in R. But every Shiny app you have is going to essentially have this user interface and server function. So here, the user interface is where you define your layout. It's where you're going to have a plotly or plot output, those sorts of things, but it also where you take input here. The reactive connection exists in sort of this reactive expression here. And so what's happening here is inside this inside the server function, we're going to have a user make a selection. So they're going to want to look at one species of penguin, let's say. So this is from the penguins data set. And so the user is going to make a selection. The choices the user are given is just specified by the unique number of categories in that data column. And then the user is going to make a selection, and let's just say we're choosing species 1. What's going to happen is your data here are actually filtered reactively. So it's reactive to this user input, and we're creating a filter here on this penguins data set and creating this essentially filtered object. So that's kind of how that happens, where user makes a selection and your backend data are filtered based on the user selection. And then what we're doing is just building a plot with that filtered data selection here. And so this is essentially like the skeleton. This is how a base Shiny app works. So you could essentially build your very own Shiny app that just sort of has a select input bar and an output. This here is that input ID, output ID sort of thing I was talking about here. So the input ID here is telling you species is going to be matching here. This is telling you to filter on that user input. And this is telling your plot output to render this plot based on the user selection. So that's sort of like, in a nutshell, how the Shiny logic works. So yeah, as I said, this was one of the things when I first started looking at Shinies, that Shiny apps and building Shiny apps, they kind of take it for granted that this makes sense. So it's fine. We can code, we can build plots, no problem. But it's kind of like getting these linkings between these things that just sort of are missed, I find, in a lot of the guides for doing this. Okay, so some packages worth knowing. So we need to know Shiny. That's essentially the core framework. If we don't know if we don't have the Shiny package, we're not going to be able to build a Shiny app. But beyond that, some of the ones we use often are BSlib. So this is typically what people are using these days. These things change. Typically, they're supported for quite some time, so it's rare that things actually become deprecated, but sort of trends and things like that change with Shiny apps too. So things we built 2 years ago don't look like things we build now. But BSlib is one of those ones where you'll see those showing up. We have, it's built on Bootstrap 5, which is an HTML protocol, and it has things like navbar page, fluid rows, how you adjust your different layouts, those sorts of things. Plotly, I really like Plotly because Plotly inherently has some interactivity built into it. It integrates really, really nice with Shiny apps for building interactive plots, but there's no reason you can't put a static ggplot into your Shiny app that just renders a different data set every single time. However, there are ways of taking a ggplot and making it interactive by wrapping it in a ggplotly function. So this actually takes a ggplot static plot and makes elements of it interactive. So this is also really nice, especially if you have things that you've already published. You want them to look the same, those sorts of things. It's a nice thing to sort of start with building in interactivity. And then also the DT package is so great. It's got sortable, searchable, and paginated tables with one function call, so it can build out really, really nice data sets and databases on your Shiny apps. Okay, so some honorable mentions. We use Leaflet a lot. We do a lot of mapping in our lab. Shiny Widgets is also really nice. It's got extended input types and formatting, things like pretty radio buttons and things like that. So things to take it beyond what just sort of the base Shiny has, as well as Shiny JS allows you to perform some common JavaScript operations just using R code. So those are the things that we typically find a lot of use for in the lab. So in terms of once you've built a Shiny app, how do we share it? So how do we deploy a Shiny application? So outputs are really, again, the placeholders in the UI. So it can go from your laptop. So the app is coded perfectly, but only you can see it. What do we do? We're going to need to deploy it. So you need essentially a server that is running our Python and is also connected to the internet. However, I will talk about a less technical way of sharing Shiny apps that I don't recommend, but happens a lot between developers and things like that. And then really your goal is to kind of come up with a live URL that's shareable because that's really nice to put in papers. It's really nice to share with colleagues, PIs, different collaborators. So your deployment requires, again, a server with R installed, the Shiny package, and your app's dependencies, something to handle incoming web traffic, and then a way to keep the app running. So it really depends on your audience and your infrastructure. So the first thing you can do is share the code. You can have a GitHub link. You can actually have a shared Dropbox folder. This happens a lot between myself and the other Shiny developer in our lab where we're working on something and I will just run the Shiny app locally. It works essentially the same way as it does in a web browser, except it's just not on the internet. So you just run the app, run the R code, and it pops up with a window and it looks like your Shiny app. This is what we use for testing. We don't typically deploy to the internet until we're happy with it. This is great for people who know their way around the code, but not great for a non-technical audience. ShinyApps.io is sort of the easiest way to do it. There is a free tier available. There's sort of this one function called to deploy. There's no server to manage. There are usage caps by tier. So free tier has less processing power and less available hours, but it does go up. However, support for this is ending in 2026. I do think that this is not something they're being super forthcoming about on the Shiny documentation. So I wanted to be clear that if you deploy with shinyapps.io in the next year or so, you're likely going to have to migrate over to a new system, which we are currently on through Posit Connect. So deployment happens through GitHub, and I can kind of show you after if there's time what that looks like. This has user authentication methods and role-based access control. You can get scheduled reports. There's version history. However, enterprise support can get very pricey. So we use the Shiny that does not have role-based access control and does not have user authentication, because as soon as you get into that, you're looking at $10,000 US approximately a year for a license. However, we're looking at about $50 US to host unlimited Shiny apps without those functionalities. So there are, again, different tiers. I recommend going through here. There is a free tier as well. So I recommend going through Posit Connect if you're just starting out now. I would skip shinyapps.io totally and go through Posit Connect because there is a free tier. And to be totally honest, what you get for free with Posit Connect is way better than some of the higher tiers through shinyapps.io. And I think it's just because they're consolidating things. And so there's less overhead for them. You can also self-host. Um, uh, Complete customization is allowed this way. It works with Docker behind an Nginx proxy. Best if there's existing infrastructure, so you already have an AWS environment. So there are ways of hosting your own Shiny app, but this has a high setup initially, and then also usage-based costs are incurred. So one of the things you have to keep in mind is there are cybersecurity risks to hosting your own app, because if somebody starts essentially, you know, doing some sort of attack on your Shiny app and getting 10,000 users to go onto your Shiny app, that's going to cost you. So there are different things. My suggestion is kind of go with Posit Connect because they do a lot of that infrastructure for you. And I do think that at least what we found is that the non-enterprise level tier is more than enough for what we need to do our collaboration and our Shiny app hosting. Okay, so I do have some time for walking through some examples, but I thought maybe I would stop here. And if there's any questions or comments, we can go through those now. And then I can walk through some of the examples that we have for our lab. And you know what, actually, before I go to that, just so I don't have to switch back to this presentation, I will give you a chance to screenshot some of these things here. So these are some great guides. Yeah, so I feel like the mastering Shiny has been really helpful, but to be totally honest, I spend a lot of time on Stack Overflow when I'm coming up with a problem, when I'm trying to solve a problem. And then we also have some links to our GitHub here, which have some of the code for some of the more complex apps we've built out. So you can poke through our GitHub and find some of that. Also, please feel free to email me if you want a copy of the slides, which with all of these resources and things like that, because I'm happy to send that out. And then I've also included a couple links to our Shiny apps. The one, the Gives 21 one was the one I demoed where we're looking at the map and the database. And then the Cave Shiny app is the Shiny app that goes with the James King's celiac paper. And so that gives you kind of an idea of sort of like some of the things we do with the Kaplan Lab. But I can also, once I stop sharing here, I can answer some questions and then walk through a couple other examples. So I know that was kind of a whirlwind tour into Shiny apps, but I'm hoping it's enough to sort of get you started, or maybe provide some tips and tricks if you're already a Shiny developer.
There is one question in the Q&A if you want to answer that now. Rodrigo says, very cool. Are you using any Gen AI to assist in the creation of Shiny apps?
In the creation of Shiny apps, no. I imagine it's probably pretty good for sort of getting your base app built out, but it will likely fail where Gen AI fails us in other types of data science. I would say that it would be, and this is partly why I didn't actually spend a lot of time on code, is because to be totally honest, you could ask a Gen AI tool to be like, build me a Shiny app that does this thing, and you'd probably within 10 or 15 minutes have a Shiny app. Where it's going to probably have a little bit more difficulty is when you get into nuances of filtering and your own data set. And so I would say it's a really good place to start. And again, that's why I didn't really offer like a base code, because it's like something that can be generated pretty quickly. On the flip side, we have actually been looking at integrating Gen AI tools into our Shiny apps so that users could actually sort of direct what visualizations they want to see from the data. This is a lot more complex. It's not working super great at the moment, but I think it's actually a really, really interesting idea to essentially have a Shiny app that hosts a data set and users being like, oh, okay, like what would this look like if this, like if this factor changed, what does our data look like? And allowing, I think it will allow users a little bit of a different way to explore the data, just because again, with a Shiny app, it's much more interactive than just a static plot, but it's limited because we can't let people explore absolutely every possible option just because we are limited to what we can code up reasonably, right? And so we have been looking at integrating Gen AI tools, but again, this comes with some risks in that there are costs with using those tools. You might want to consider user authentication in that case so that you can restrict the number of users actually using your app so that you're not incurring costs of, you know, 20, 30, $50,000, those sorts of things just to generate plots online. So this is something that we've been considering. But I think like in terms of actually starting with building your own Shiny app, it's a really great place to start.
Thanks. Seems like a really cool use case. I don't see any other questions in the chat or the Q&A at the moment.
Yeah, so I see here a comment about this 14K USD for 10 users. Yeah, so that was something when we first started having these conversations were about a year ago, and our lab honestly decided that we can do a lot with what they offer for the non-enterprise tiers, because we can. So, I mean, one of the considerations with the Shiny apps is that we create them with only published data, so things that are available already, and we also make sure that there's no individual level data on our Shiny apps. So we kind of skirt the role-based access control and user authentication in that we actually don't have anything in our Shiny apps that doesn't already exist in papers or elsewhere, systematic review data, things like that. So one of those considerations to make for us was that just kind of added something that we didn't really need, and we find that the lower tiers for the Posit Connect are working just fine for us.
I'm guessing you mostly code in R then, not much Python.
So our Shiny apps are all built in R. I'm bilingual, I guess, is what I'll say. But I would say Plotly has a lot more support in Python, but Shiny has a lot more support in R. And so there are things where some of our code kind of we use reticulate and things like that in our R code where we kind of do some things with Python in R. But most of our Shiny apps are built through R. And if you do look at our GitHub, you're going to see all of those things are going to be in R coding. I would say I haven't tried to fully build a Shiny app in Python. It wasn't supported, I want to say, until about 2021 or 2022. So it is newer, but essentially anything you can do in R, you can do in Python and vice versa for sort of your base Shiny apps. Yeah.
That's interesting. Yeah, because I'm much more comfortable with Python and
Okay.
R, a little bit of R, but not nearly as much Python. So I really like Plotly, but haven't
Yeah.
done much with Shiny yet.
Yeah. And I think, yeah, like it's, I think it will, like, as I said, it's going to be seamless no matter what direction you choose. But yeah, I do think like some of the things that we get Plotly to do with R, we have to kind of do through a Python, like a Python lens because it ends up working better. Um, and I mean, and I will be honest about one of the sort of interesting difficulties we have is because we kind of build a lot of our plots out to work in Shiny, we do a lot of Plotly, but it's not the best for static images. So I would say we default would be ggplot for static images, but then when you're building out plots in Shiny that you might want to take as static images in your publications, it's a lot harder to go from an HTML plot to a static image, right? And so there's kind of a trade-off there as well. I'm gonna, if everyone has a few more minutes, I'll share my screen again and walk through Shiny apps if there doesn't seem to be any more questions. Okay. So here, this is the Shiny app that I had a screenshot of at the beginning of the talk. So this is our celiac disease analytical visualization environment. And this goes along with actually now a couple papers. So what we've been doing so far is kind of building out. So we have an incidence and testing paper with the Shiny app. We have some 3D plots. And then there's a new paper with some time series data as well. So we've been kind of building out tabs for studies so that we kind of house everything under this what we call cave environment. But then one of the things we've actually looked at doing is, and I'll show you a Shiny app from another project here. Oh, there we go. Okay. It's not the one. Sorry, for some reason, there we go. So this one here, we've actually been working with some sites globally on visualizing COVID data and integrating COVID data into one massive dashboard. And this is where we've actually built out different studies into our Shiny app. This has required us to do a little bit more complex things than just sort of your base Shiny, because there is some web navigation involved here. I'm not a web developer, but I was able to get this working. But essentially, we have a study here. It's going to run a little bit slow here, where we can click on a site. So we have the University of Calgary. It's populating some data here. With this one in particular, we also have this nice demographics dashboard as well, where we can essentially look at data from, we might want to look at just a couple places, and it updates the dashboard for us and allows us to compare across sites. We can do some comparison of studies this way as well. And so this is one of the apps we've built out for this COVID project. But it's nice because we also have um, essentially this like multi-study dashboard. And this is something that we're looking at currently building out for the cave environment, just because now we're getting, 3, 4, 5 studies globally. And so we probably want to build out a nicer way than just having tabs run across the top here. So we're looking at building something out a little bit different. Here, this is from a project on forecasting the incidence and prevalence of IBD across some stage 3 countries. And what I really like about this one is we actually have built in an interactive plot to our map that takes map clicks and builds a plot accordingly. So we can see here, let's say we want to look at let's look at data from adults from 2019. Here we can make a map click and it actually populates our plot, which we can then pop out and we can look at interactively as well. So these sorts of things update with all of the clicks. And so it seems like it's kind of like a very simple thing to do, but in the back end, this is sort of where like these reactive inputs take. So it would say like users clicked on Canada, filter data for Canada, and display Canada is essentially how that workflow works. And so I have here our GitHub, and we can kind of look through. I'll go back to, actually, why don't we just look at the cave? We can see those things like the sidebar layout that we looked at. This is sort of our select input. So this creates a drop down. What the user sees is provincial. What is in our data set is this level of our variable called geoprov, and it filters accordingly. So what's nice is this is all in R code, or again, Python, if that's what you want to build in. But what's really cool about these things is that what Shiny does essentially for you is translates all of this into code on the side here. So we can see here, this is just inspecting the HTML code, but this is not something we've had to do. We've done this all in R, and it's essentially built out this whole website for us. So we can kind of see like when things happen. So if we want to, let's just inspect this again. It's essentially reactive to our clicks and those sorts of things. So that's essentially all Shiny is doing, is taking your R code and translating it into something that is HTML based. So it's nice again that you can build these web apps and not have to actually know any of the HTML coding. That being said, we tend to build in some of our own So I think in our app here, we see a bunch of HTML coding because we find sometimes we can make different formatting things that Shiny will kind of say these are your, 6 to 10 options, and we're like, but we want this option or we want this icon and those sorts of things. So you can build this in, and this is actually where Gen AI might actually be helpful because you can be like, I'm building a Shiny app, but it takes this, I want to do this with HTML. And that I think would be a really helpful thing to do to integrate. The way we structure our apps is modular. So essentially we have this app.r file, which just essentially says, take all of these things and all of these modules and put them together into one Shiny app. And the reason we've done this is so that we can make changes to essentially a single study or a single plot, things like that, without having to worry about breaking our entire Shiny app. So if we break one of these modules, the app is still going to be functioning. And so we do something called modularizing, and I would highly recommend looking into how to do that. It's not terribly tricky. It just, again, it adds another level of that linking across different elements. And so in this case, what you're doing is essentially what you have to do is essentially wrap everything in a namespace, and that will allow you to modularize. And again, that's one of those things where, when you look at our first Shiny apps, none of them were like that. It was one of those things, if we broke a plot, the Shiny app was just like, it wouldn't work. So now we've kind of got those tricks in where we've modularized everything. We have our data in this global. So again, if we change data, we're changing one section of our Shiny app and not affecting the entire Shiny app. So that's been really nice for us in terms of like updating and things like that. Yeah. Okay. Well, we're almost at the top of the hour. I don't know if there's any other questions.
I don't see any yet. Maybe I'll ask one more. Have you tried
Okay.
looking at like mobile stuff? How does Shiny do on mobile?
So it's tricky. Our Shiny apps typically don't translate to mobile very well, but we've started using what are called cards. And cards will auto adjust to the screen a lot nicer. So that's something you'll want to look at. And so what it is it's a system where essentially all a card is like, it's like a little chunk of your Shiny app. And what's great about it is on mobile is they just shift to a mobile screen. So you end up scrolling and things like that. We find that mobile is not necessarily the best place for exploring data anyway. So when we're sharing QR codes, usually what we'll do is create a Shiny app with a redirect that will allow people to scan the QR code, and then it takes them to a sort of like snapshot of the Shiny app, and then it says like best viewed on desktop, because we find that overall it's really hard to explore a spreadsheet on mobile anyway. Like you can do it, but like it's tough. So the card system helps quite a bit. There are ways of making a Shiny app mobile friendly, but earlier versions essentially you had to recode an entire Shiny app for the mobile device. And so the card system, I think, is sort of a nice sort of intermediate solution where it will sort of auto shift to tablet size or mobile phone size really nicely. And it's just essentially all you're doing is wrapping each of your outputs in a card. And it's nice. So that's something to look for as well. So that's a great question.
Cool. Well, thank you very much for the presentation today. The presentation will be posted online under the CHI website under the event section. So if anyone wants to go back and watch it and catch some other links or QR codes that they want to reference. But if there's no more questions, I think we can thank Lindsay and end it here. So thanks so much. That was interesting.
Thanks so much for having me today.